Thank you very much, everyone, for being here. And today you will learn about how to remember what you learn. And we will also speak about the essential Python libraries for your first data science project, and actually the fundamental pandas tricks, so as to deal with, let's say, large-scale data. So the first problem that I faced when I started learning about machine learning was that I couldn't remember the derivatives. But I have spent so much time in high school trying to learn about calculus. So why this happened? Why this happened? Yeah, because learning is not an instant thing. It demands by your brain to store the new piece of information or behavior, in this case the gradients, in the long-term memory. So sometimes happens something like this. So the forgetting curve is one theory from cognitive psychology that helps us to explain why learning is hard. So what is it, the forgetting curve? The forgetting curve tells us that through time, since the first time that you interact with a new knowledge component, let's say derivatives, since the first time, this knowledge tends to decay over time exponentially. And here we can see the formula. So the y represents if you are able to recall these informations, let's say derivatives. T represents the time since you first study this information. So we call this lag. And 8 is really important. We call this half-life, and it tells us what is the strength in long-term memory of derivatives. So when this curve is flat, this means that I've just practiced derivatives, so it's still fresh in my mind. But what should I do now? How to fool the forgetting curve so as to remember the derivatives from now on? So one technique is actually one model is called space repetition. Repetition, because I have to repeatedly test myself on derivatives, and space, because this repetition should be, instead of mass, should be spread it over time. And here we can see the forgetting curve. Here it is the first recall of derivatives, and we can see that because of the forgetting curves, one recall isn't enough, one recall of the derivatives, so I have to make many recalls over time so as to remember what I learned after a long period of time. But the next interesting question is, how many times should I do this review of derivatives? Like forever? And then I found the two most famous space repetition models, which are used especially in linguistics domain. And these are called Pimsleur system and Leitner system. Let's take a look at the first one. The intervals that it takes are fixed, so like after 5 seconds, after 25 seconds, and then after 2 years, if you are able to recall the derivatives in this case, then this is going to be stored in your long-term memory. The second model, the Leitner system, is a bit more adaptive. Why? Because instead of just using fixed intervals between my reviews, it says, okay, I will decrease or increase the interval based on your performance, based on if you were able to correctly recall derivatives or not. And each time I correctly recall the derivatives, then it halves. It halves the intervals, whereas each time that I incorrectly recall, it doubles it. That's all good and nice, but then I said, are there any data available outside there so as to see if I could get rid of these hand-picked parameters and see if I could use real data of students so as to see what works and what doesn't? Or even take one step further and try to find, is there any online learning platform that already make use of this model so as to improve, to help the learner don't forget what he tries to learn? And I found something. I found Duolingo. Duolingo is an online learning platform which is used by many students around the globe when they want to learn a new language. Yeah, and what it does, it generalizes the two previous models, the Leitner and the Pilmser. And how does it do that? With half-life regression. And here we can see two examples of how does Duolingo uses it. So every time that I practice, now not the derivatives, but a new word in a new language, let's say Dutch, I am able to see how strong is, feel pleasured in my mind. Is it still strong in my mind, this word, or is it is going to overuse? So I'm going to forget the next time how to say have fun to my colleagues. Another example, besides the memory progress bars, it also uses the half-life regression so as to recommend me what kind of words should I review before this overdue. So instead of just trying to unlock the new skill, which in this case is measures, maybe I should consider to make a review for what I have learned up to now. But the next, blessed question is how half-life regression works. So half-life regression tries to, it combines forgetting curve with basic machine learning techniques so as to find the boundary between the correct recall and the incorrect recall. And here because we are going to, this is the first data science project of a potential data scientist, the first that we should know is that every machine learning model, even if it is something super technical like deep learning, every machine learning model contains three components. We have to build the model, namely what kind of data are important and what is the model structure. We have to train the model, so how to optimize the function that I'm trying to optimize, and how to test, to see how this works with data that my algorithms have never seen before, how to predict. So let's see how half-life regression characterizes, let's dive into the first step to build a model, and let's see how half-life regression characterizes the human learning in this case, So here we can see the data that we use for half-life regression. So in total, we have 4 features. So before we're able to predict the future, we have to see what is the past. And here we can see here we can see the previous exposure of a learner with a word, so how many times he had a correct recall, how many times a wrong recall, and actually how often does he or she interacts with this specific word. And the lexeme string actually is a word, but it has got it is attached to part of speech tags, the lemmas, morphological features. So this is the content feature related, and the other three are considered the interaction features of the users. And in total, we have more than 100,000 of students onto 2,000 words. And both these two, and each data, here we can see an example of the data instances. And each data instance represents the correct recall. So we have got labels for our data. We know if someone would be able in the future to correctly recall the word. The T, which is the lag time, when did he start practicing this word. The half-life, which is super important for our algorithm, the user ID, and the lexeme ID. And now I'm going to introduce the first most basic data science library, which is the one used here as well, and also it is going to be used, to explore our data. But what we care, firstly, let me say that Pandas is the most basic library, most probably we all know that, so as to manipulate the data, import and export and import CSV data through or export, and we do that with data frames. And when we have large-scale data, there are some tricks that could help us to improve the performance of our algorithm. And here we can see that with read CSV, with the read CSV method, I can pick for the parameter called chunk size so as to load my data into different chunks instead of loading them all at once. What I missed to say is that in total we have got 13 million traces of students. Yeah, 13 million. And now we upload them by 10,000. Yeah. Another method that I could use is called .info. And this one can give us information about what kind of columns do our data have, what data types are these data, and how many data instances have I got totally. And after I do that, it's pretty important to also drop the columns that my model isn't going to use, so as to not take them into our code. And another method is called as-type. So it's important to, for performance reasons, it's important to convert our float or int integers from 64-bit to 32. I can already show you how. Yeah. Let me give me a minute. And I can already show you how memory efficient is this. So here you can see that I am using the command .info so as to see the columns of my data and their data types. And I can observe that most of them are of float 64 or integer 64. And it consumes a memory usage of 1.1 gigabyte. And after that, after I convert them to float 32, I can already see a big difference into my memory usage. In this case, 800 megabyte. So let me go back to the presentation without seeing my notes. So now that you are convinced that these simple methods have got super useful parameters, another really useful library is called matplotlib. It's really useful because this is usually the straightforward library that you're going to use for data plots and exploration of your data. Or the distribution of the features if you want to get an insight of what kind of data do you have. And this is for the first step, for how to build the model, how to see what kind of data do we have. And now let's move forward into the model structure, the structure of half-life regression. And remember that the half-life regression is the exponential function. And here each time I actively recall a specific word, I see that this also exponentially increases. So here we can see, the formula that we've already seen. And what half-life regression does in addition to that is that it tries to optimize also towards the half-life regression. So how strong this is into my memory, this word. And this is important because I should revise it exactly at the point that my mind is almost going to forget it. So when you're at this edge, you should recall it. And here we can see the red dashed line represents the estimated model that tries to minimize the distance between the observed recall rates, because it's a supervised learning problem. And what I didn't say is that for half-life, since we assume an exponential growth, we see the exponential function of the weights multiplied with the features, weights or parameters. So the second step is to train our model and to validate it as we've seen. And more specifically, the common choice for a regression model, it's as a cost or objective function, is the squared loss function. So what we want to do is to minimize the difference between the estimated values and the real values. And we do that with trying to optimize the square loss function. And because the parameter space is somehow big, I should find a way to deal with the overfitting problem. What is that? That is when our model just memorizes the data instances, and instead of finding the true function of the model, just memorizes the data instances, and that makes it unable to predict for data instances that has never seen before. And we are doing that with Reed's regression, which is this regularization term here, which penalizes the weights of the features. But how can I learn the weights for the features? So to learn the weights for the feature, we will use gradient descent, which is widely used in machine learning, and it is used for minimizing differential functions with many parameters. So my friend calculus again, and it is used to find the gradient of the cost function and update the values for the parameters with this simple update rule. And at this point, we should make two decisions. What should be the learning rate, so the size of the change of the parameter values? And here an advice is not use a super big learning rate because it's going to surpass the optimization point, but neither a super small learning rate because it is going to be super slow. And the second decision that I have to make to the optimization part is what portion of training examples are going to be used to update the values. All of them at once or in batches. So how to predict in data, for data that my model has never seen before, how to evaluate. So as an evaluation metrics, we use the quantitative one of the mean absolute error to quantify how close the predictions were with the real values, and two qualitative ones, the Spearman rank correlation, which measures the statistical dependency between the real and the estimated one, and the other one is the RO curve, which measures the ability of the algorithm to distinguish the real the correct from the incorrect recall rates. And that's also another example for where we use matplotlib to plot this parameter. So the third library is called scikit-learn library, and we used it so as to implement machine learning algorithms. So the code for Half-Life Regression by Duolingo is built by scratch. So with pure Python, which is pretty nice, but it's not super flexible, and you cannot play with model selection stuff. So instead of building all this math stuff from the beginning, it would be nice to use scikit-learn for the machine learning algorithm that we want to implement. But before doing that, we have to convert our data frames into vectors and matrices, because this is how machine learning models work. So NumPy is the library. From NumPy, we should use ND-array, which is for fast and space-efficient multidimensional array. And we can use vectorized functions instead of loops, which is more efficient. And in this, maybe at this point, the problem that I at least faced while I was starting learning machine learning is that all the errors that I received wasn't about how the flow of the machine learning model or the data science project were, but all the errors were broadcasting errors. So I didn't use I didn't follow the correct broadcasting principles that NumPy implements, so as to make the operations between vectors and matrices to work correctly. Then in scikit-learn has already got an implemented function which is called because it's a linear regression model, so we can find it into a linear model. And SGD stands for stochastic gradient descent. And down we can see, yeah, that we can opt for the loss, so in this case, squared loss. We can opt for the penalty, so the regularization term, the one who is going to penalize the weights. The alpha is the one who is going to put importance, how important is half-life into this objective function, and the learning rate, so how fast should gradient be updated. And another, the fifth and the last library is the SciPy, the last fundamental library is SciPy, and provides us with statistical functions, and in this case provides us the Spearman correlation metric. So, yeah. So, yeah. Now, maybe I should say something about what are the best practices while you are building your machine learning code for a model. So, what is considered as a good practice is to firstly define the model structure, so like the data inputs and the hyperparameter values. Then as a second step, we initialize the model parameters. In this case, in linear regression, it doesn't so much matter if you're going to randomly initialize the weights, but in neural networks, it matters how do you initialize your parameters. And the third step is, yeah, to calculate the loss, so the square loss, yeah, to calculate the gradient and to update the parameters with the gradient descent, and these three steps integrated into one function, and usually we call this one model, in this case, space repetition model. And what is important, another, not best practice, but mostly like an advice regarding machine learning is that we should always stop and debug, always judge ourselves, always say that what is the cases that this model is going to fail, it doesn't going to work. So let's be critical, and we should do that before accepting that this model should go into production, should be implemented into my learning online learning platform. Why? Because if it overfits, then it's going to. What happened in this case that users were super frustrated because despite how long they would practice, some words would decay rapidly, and that was an overfitting problem. Despite there was used regularization. So regularization is not always enough. And specifically, the lexeme tanks led to overfitting. Yeah. So, since we're speaking about, since we are talking about how to remember what you learn, and it would be nice to leave this room by just remembering at least one thing. Don't be hard with yourself. Just remember only one thing from these 6. So let's begin with the first one. How did we start? We started that it's difficult to learn new things. And forgetting curve is a theory that tells us that, okay, it's all about time and memory strength of this knowledge unit, of this behavior that you are trying to learn. Okay, how can I fool you? I can fool you by using space repetition model. Okay, what is this about? This is all about time and review. Revision is boring, but it's effective. The third is, what is half-life regression? Okay, it's a linear regression model, but what is it about? It's all about the forgetting curve, linking the forgetting curve, so a cognitive science theory with machine learning techniques. And simple machine learning techniques in this case. The fourth one is, okay, since I'm new in data science, what is machine learning? Machine learning is always composed by the 3 things. How to represent my problem and what are my data are representative for this problem. Optimization, I'm trying to optimize this function. I'm trying to find what this function is, and to always evaluate into test data, into data that your algorithm has never seen, hasn't trained before on that data. The fifth is the overfitting, which sometimes most of the times we use regularization so as to overcome it, but we should always diagnose before production. And the basic fundamental libraries for any machine learning model is the SciPy, for statistical stuff, the NumPy for doing vectorizations and converting our data to vectors, Scalar for using different data sets to play around and using already built models, many models, Pandas, so as to explore my data and import or export data instead of using the CSV reader, like plain Python, and Matplotlib or Seaborn, maybe, if you prefer better visualizations. And I will end this talk with some questions. Besides this takes awake. The questions are, first of all, features is the most important thing in every machine learning model. And we can already see that into the hackathons and many hackathons, that usually the machine learning models are not the most difficult and complex ones, but they are the ones that have done nice feature engineering things. So in this case, for memory decay, maybe I should also use user feedback so as to see, because in the beginning the forgetting curve tends to always recommend you the same word, so as to verify that you know this word. But users get frustrated, so it would be nice to say, okay, don't show me this again. Please, I master it. Also to use more generic content features, because previously we saw that actually it was the lexeme tags that led to overfitting, and by broader lexeme tags, less dense, and another maybe interesting feature, since we are speaking about, let's say now, languages, is a similarity between the native and the learning language. If I'm trying to learn Dutch and my native language is Greek, it's going to be much more difficult than for my native language to was, let's say, German, because they have more similarities, these two languages between. Another interesting thing is that we always observe in learning, in online learning, happening these things, that we assume independency. But this domain is highly dependent. And in this case, the reviews are always dependent with the content and between the review and the reviews between them. The second question has to do with quantitative domains, like that one of statistics or of linear algebra. Up to now, we've seen the space repetition model to be applied into linguistics, linguistics domains. And we assume that this hasn't happened before in quantitative domains, because space repetition requires for each piece of knowledge to be really, really fine-grained, like in the form of a flashcard. And linear algebra, for example, is really difficult to do that, because everything, like derivatives, is usually highly interdependent with, let's say, differential functions. And the third and the most important one, which is the ultimate goal, is how to optimize human learning. In this case, in online learning environments, because we've already seen a big wave of users just using online learning platforms to learn something new. So the ultimate goal is how to make revision fun and not let our users to quit. I don't have much time to show the demo, but the end is that we hope in the future that machine learning is going to help to improve online learning as well, despite other more technical domains. So that's my presentation. Thank you.